On Christmas Day in 2021, we, space lovers, had another type of Christmas. As you already know, humanity had another achievement and the James Webb Telescope was sent in space. So if you're an atheist or you have faith in another religion, you can celebrate Christmas as the birth of another era of exploration of space. And in any way, as you are watching this video, hit that like button, comment your opinion and subscribe. You don't know it yet what we are going to talk about in the next videos, so trust me, you must see our future videos. James Webb Telescope. We heard those words every day for nowadays. Then, who was that James Webb? James Edwin Webb was the second administrator of National Aeronautics and Space Administration, so-called NASA. For 7 years after President Kennedy, May 25, 1961, lunar landing announcement, through October 1968, James Webb politicked, coaxed, cajoled, and maneuvered for NASA in Washington. As a longtime Washington insider, he was a master at bureaucratic politics. In the end, through a variety of methods, Administrator Webb built a seamless web of political liaisons that brought continued support for and resources to accomplish the Apollo moon landing on schedule President Kennedy had announced. He was one of the founders of Apollo mission and did a great job for humanity in exploring space. After returning from NASA, Mr. Webb remained in Washington, D.C., serving on several advisory boards, including as regent of the Smithsonian Institution. He died on March 27, 1992, and is buried in Arlington National Cemetery. Every new telescope put into space has always found something they didn't expect, something new. Telescopes are time machines, and the Webb telescope can push us back into the realm of the first stars and galaxies when the universe was like 100 million years old. It also can help us to study the atmosphere of other planets, so we can search for life there. Until the Hubble telescope, every other one was only on the ground, so they couldn't see so far. The Hubble telescope was the potential to reach out further into the universe. But as it was first one out there in space, we didn't know what was there and how far we could see clearly. The first stars that turned on in the universe, or the first galaxies, were probably very bright objects that emitted a lot of ultraviolet light. But that light was a very short wavelength, and it has been traveling through a universe that's been expanding for about 13.5 billion years. That short wavelength, as it travels through all that time, gets stretched out so that by the time it reaches us, it's no longer ultraviolet, it's infrared. When we look at the universe, there's a lot of dusty dark areas, but one of the greatest things about infrared is light can travel through the dust. The dust becomes almost transparent, so if we're trying to see how stars and planets form in their early time, the infrared is a great possibility. So, maybe now you can guess how great the Webb telescope is. Just a little reminder that you should wait until the end of this video. We have the top 4 interesting facts about the Webb telescope, as its name contains 4 letters. Okay, back to the topic. Now that we know the Webb telescope can detect infrared lights, let's explain how it does it. It will be assisted by a huge mirror, which will increase the amount of collected light. The lighter, the more detailed the image. The mirror is made with 18 hexagonal segments, each one 1.32 meters in diameter. The telescope will operate on a point so-called L2 point, which is 1 million miles away from the Earth, on the opposite side of the Sun. There it can put up a sun shield, a big umbrella, and it can block out the Sun, the Earth, and the Moon at the same time. This is obviously no ordinary umbrella. The 5 individual layers are made of an almost plastic-like material called Kapton. 200,000 watts of solar radiation strikes the hot side, and the sun shield will only allow about 0.02 watts to get through. Until the Webb telescope analyzing, the exploration target needed a long time. Telescopes needed to stare at an object may be ages, and this problem should be solved with a Webb telescope. To solve the issue, the new telescope is equipped with microshutters. The microshutters are a new technology that was developed for James Webb Space Telescope mission. They are basically tiny windows with shutters that each measure 100 by 200 microns, or about the size of a bundle of only a few human hairs. Arrays of these tiny windows are a key component of one of Webb's instruments, the near-infrared spectrography, or NIRS spec. The telescope has 4 other main components to do experimentally hard work with maximum efficiency and quality. NIRS is the telescope's primary imager. In the near-infrared range, 10 sensitive detectors allow it to detect the light of the first stars and galaxies. In addition, NIRS is equipped with coronagraphs. And what are they? Imagine that you're blocking the sun with your hand. By blocking the bright light, you can see the road ahead of you. A coronagraph follows a similar principle. This function will allow researchers to see more faintly lit stars, galaxies, and even take photos of exoplanets. But NIRCam cannot show us everything we need to know about the physical properties of a planet. Is there water? Air? Impossible to say. The near-infrared spectrography, NIRSpec, will operate over a wavelength range of 0.6 to 5 microns. A spectrograph, also something called a spectrometer, is used to disperse light from an object into spectrum. Analyzing the spectrum of an object can tell us about its physical properties, including temperature, mass, and chemical composition. The Fine Guidance Sensor (FGS) allow Webb to point precisely so that it can obtain high-quality images. The near-infrared imager and slitless spectrograph, part of the Fine Guidance Sensor and NIRS, will be used to investigate the following science objectives. First, light detection, exoplanet detection, characterization, and exoplanet transit spectroscopy. The mid-infrared instrument has both a camera and a spectrograph that sees light in a mid-infrared region of the electromagnetic spectrum with wavelengths that are longer than our eyes see. MIRI covers the wavelength range of 5 to 28 microns. Its sensitive detectors will allow it to see the redshifted light of distant galaxies, newly forming stars, and faintly visible comets, as well as objects in a Kuiper belt. Now, we know what a telescope can do and how it is done. Let's count the 4 key facts about the Webb telescope as I promised you. Fourth, the mission is, as we today know, will last for 5 to 10 years. Third, the total payload mass is approximately 6,200 kilograms, including an observatory, on-orbit consumables, and launch vehicle adapter. Second, telescope orbit is 1.5 million kilometers from Earth, orbiting the L2 point. First, the primary mirror material is beryllium-coated with gold, and the mirror itself weighs 705 kilograms. That's all for today. In this video, we covered the main event in the last period. Hit that subscribe button so you can keep up with the news in space, science, and also get some old facts that are so interesting. You shouldn't totally skip our videos.